Welcome to the DIY Honda Garage channel. Hello everyone, today we're diving into the DTC P0135, which indicates a malfunction in the AF sensor, specifically related to the heater circuit in a Honda CRV from the years 2011 to 2016. This diagnostic trouble code, DTC, points to potential issues affecting the air-fuel sensor, AF sensor, which plays a critical role in adjusting the air-fuel mixture to ensure optimal engine performance and emissions control. The AF sensor is usually located in the exhaust manifold or near the catalytic converter. It provides feedback to the engine control module, ECM, about the air-fuel mixture by measuring the oxygen level in the exhaust gases. Understanding the implications of this DTC is essential, as it can lead to poor fuel economy and increased emissions if not resolved promptly. The investigation of this code typically involves examining various components associated with the sensor's heater circuit, testing wiring, and ensuring that proper continuity exists throughout the system. The error description of DTC P0135 indicates a malfunction specifically related to the heater circuit of A-fuel sensor 1. This sensor is integral to maintaining the correct air-fuel ratio, as it helps the engine's management system in making real-time adjustments for optimal combustion. The A-fuel sensor is typically positioned near the exhaust manifold or catalytic converter, exposed to high temperatures and exhaust gases. Its heater circuit is designed to rapidly reach and maintain the necessary operating temperature, ensuring that the sensor provides accurate readings. When this circuit fails, it can trigger a series of performance issues, including increased emissions and fuel consumption. Addressing this DTC quickly is crucial to maintaining vehicle performance and compliance with emission standards. There are several possible causes for the P0135 fault code. Firstly, a faulty air-fuel sensor can be the primary reason, indicating that the heater circuit within the sensor may have failed, preventing it from warming up properly. A blown fuse, specifically fuse number A18, can interrupt power to the sensor or its heater circuit, leading to this DTC. This 15-amp fuse is located in the underhood fuse relay box, and keeping it intact is crucial for proper functioning. Additionally, issues with the powertrain control module, PGM-FI sub-relay, are another common cause. If the relay is not functioning correctly, it can fail to supply adequate power to the sensor, resulting in circuit malfunction. Each of these components and connections must be systematically checked during the troubleshooting process to identify the root cause of the issue. When dealing with DTC P0135, several symptoms can arise indicating a potential issue. The most noticeable symptom is the illumination of the check engine light on the dashboard, signaling that a malfunction has been detected in the emission control system. Additionally, drivers may experience a noticeable decline in fuel economy due to the incorrect air-fuel mixture. Increased emissions may also occur, leading to potential complications during emissions testing. As the AF sensor's functionality is critical for achieving an optimal fuel mixture, any malfunction here can lead to performance issues, reduced engine efficiency, and a failure to meet environmental standards. Understanding these signs is important for vehicle owners to address issues early and avoid costly repairs linked to ongoing driving with the DTC present. For the first troubleshooting step, begin by turning the ignition switch to the on position. This step ensures that the vehicle systems are activated, allowing for proper diagnostics. Next, you will need to use the Honda Diagnostic System, HDS, to clear the DTC from the system. This is crucial because it helps reset any stored codes, including P0135, from memory. Following this, start the engine and raise the RPM to 3000 without any load. maintaining the speed until the radiator fan engages. This helps the engine reach the appropriate working temperature while the AF sensor is operational. Finally, check for any pending or confirmed DTCs once again with the HDS. If P0135 reappears, there is a confirmed failure. However, if not, this could point to an intermittent fault, suggesting further examination of the AF sensor and related connections. In this second step, you begin by turning the ignition switch to the lock position, 0, ensuring all electrical systems are off. This is a safety precaution before engaging in any diagnostic work. Next, focus on checking fuse number A18, which is a 15A fuse responsible for powering the AF sensor heater circuit. This fuse is located in the underhood fuse/relay box, and it's essential to ensure its integrity. If the fuse is blown, this can immediately disrupt power to the sensor, triggering the DTC P0135. If the fuse is functional, you would then proceed to the next diagnostic step. However, if the fuse is defective, replacing it is necessary before continuing the troubleshooting process to restore circuit continuity. For Step 3, begin with the removal of the PGM-FI subrelay from the underhood fuse relay box. The subrelay is an important component within the power management system, supplying power to various engine control systems, including the AF sensor. After its removal, conduct functionality testing on the PGM-FI subrelay to determine if it is operational. This can involve checking for continuity and making sure that the relay switches correctly when voltage is applied. If the relay functions properly, you will be directed to the next troubleshooting step. However, if it does not work, replacing the subrelay becomes necessary to restore the circuit functionality, allowing the AF sensor to operate correctly. In Step 4, start by disconnecting the AF sensor, Sensor 1, 4P connector to isolate the sensor from the circuit. This involves safely detaching the connector to minimize interference when taking measurements. Next, you will measure the internal heater resistance between test points 1 and 2 on the sensor side. It's crucial to ensure that the conditions are correct. The ignition should be in the lock position, 0, and the PGM-FI subrelay disconnected. The ideal resistance range for the AF sensor heater is between 2.2 and 2.7 ohms at room temperature. If the measured resistance falls within this range, the sensor is functioning correctly, and you can proceed to the next step. If the resistance is out of spec, replacing the AF sensor becomes necessary to resolve the malfunction. In the fifth troubleshooting step, continue by checking the continuity of the AF sensor's internal circuit. After ensuring that the AF sensor, Sensor 1, 4P connector is disconnected, you'll test for continuity between specified test points 1 and 2. This test condition remains the same, with the ignition lock in position 0 and the PGM-FI subrelay disconnected. Here, you will utilize a multimeter to verify proper circuit continuity. If the continuity is present, it indicates that the sensor is functioning properly, leading you to replace the sensor if resistance is below the specified range. Conversely, if there is no continuity, proceed to the next troubleshooting steps to identify and rectify potential wiring issues that could be affecting the circuit. In this sixth step, start by jumping the SCS line using the HDS, which essentially sets up the vehicle for diagnostic testing, bypassing certain safety protocols. Following this setup, proceed to disconnect PCM connector C, which houses several crucial circuits for engine management, including those relevant to the AFAT-F sensor. After isolating the PCM, you will check for continuity between the designated test points for the AFHT line. Continuity at this stage is critical, as it indicates whether the heater circuit is intact between the AFAT sensor and the powertrain control module, PCM. If continuity exists, it suggests no issues with the wiring. However, if there's a break in continuity, you must repair the open circuit in the AFHT wire to ensure proper sensor operation. Step 7 focuses on checking the continuity of the LEF Plus sub-RLI out wire. This circuit is critical for the successful operation of the AF sensor and requires you to ensure uninterrupted connectivity. Continuing with the same diagnostic conditions, verify continuity between test points 1 and 2, which are connected to the PGM-FI sub-relay and the AF sensor. A successful continuity check indicates that the wiring is intact and functional, which is essential to maintain power flow to the sensor. However, if continuity does not exist, it points towards a potential open circuit. Diagnosing and repairing any issues along this line is necessary before continuing the troubleshooting process. In the 8th troubleshooting step, disconnect the PCM connector A while keeping the other connections isolated to ensure effectiveness in testing. Subsequently, check for continuity on the FI sub-relay CL line to verify the circuit's integrity. This line is critical for the overall operation of the AF sensor and the PGM-FI sub-relay circuit. Like previous steps, ensuring continuity is essential. If it exists, it suggests that the circuit is operating as it should. Conversely, if there is no continuity found, you'll need to repair an open in the FI sub-relay CL wire. Such an issue could be critical, as it can directly affect the relay function and ultimately the AF sensor's performance, leading to erroneous readings and potential engine performance issues. In the final troubleshooting step, start by removing the PGM-FI sub-relay and the AC condenser fan relay from the fuse/relay box. This helps isolate the circuits for a thorough test. With these components removed, check for shorts in the LAF Plus FI sub-relay outwire. This involves ensuring that there are no unintended connections or faults that could be causing the heater circuit to malfunction. Conducting a visual inspection of all associated wires and connectors. Looking for signs of wear, damage, or frayed insulation is necessary during this process. If a short is detected, any repairs must be made to restore functionality. If no shorts are found, verify the integrity of the underhood fuse/relay box. Any failures here can lead to improper relay operation and should be replaced to resolve the DTC. To complete the troubleshooting process, begin the final repair verification by turning the ignition switch to the lock position, 0, to ensure all systems are powered off. Follow this by reconnecting all connectors that were disconnected during the troubleshooting process, ensuring each connection is secure to prevent future diagnostics issues. After reconnection, turn the ignition switch to the on position, 2, and proceed to reset the powertrain control module, PCM. Using the Honda Diagnostics System, HDS, this reset allows the PCM to relearn any new configurations after repairs. Finally, monitor the OBD status for DTC P0135 within the HDS menu. A past status confirms that the repairs were successful and no further issues are detected. If failed or not completed statuses appear, you may need to revisit earlier steps to ensure that all connections and components are in working order. Preventive maintenance is crucial to avoid reoccurring DTC P0135 issues. One key step is to regularly inspect the electrical connectors associated with the AF sensor and its circuits. Ensuring that connectors are clean, dry, and free from corrosion can prevent intermittent failures. Additionally, it's important to replace any blown fuses promptly, as neglecting this can lead to more extensive system issues. Maintaining the sensor's cleanliness can also aid in its effective functionality. A dirty sensor can lead to inaccurate readings, resulting in poor engine performance. Keeping an eye on wiring integrity, checking for frays, cracks, or wear will also improve the longevity and efficiency of the AF sensor's operation. Adopting these proactive measures makes it less likely to encounter issues that could trigger the DTC in the future. In summary, understanding DTC P0135 and its implications is essential for maintaining the performance of the Honda CRV from 2011 to 2016. The A-fuel sensor plays an integral role in achieving the correct air-fuel mixture, impacting not only vehicle performance, but also emissions compliance. The troubleshooting steps outlined guide the technician through systematic checks, isolating potential faults in the A-fuel sensor circuit. By thoroughly investigating each component, from fuses to wiring and relays, you can effectively diagnose and resolve issues related to this DTC. Continued monitoring of the vehicle's performance and routine checks of sensor connections can also promote long-term reliability and prevent future occurrences of this error code. Please like and subscribe to the channel. See you next time.